Hey guys, let's go ahead and start notes for day 6. Today's lesson is on the Pythagorean identity, but I wanted to show you this really cool thing with what we've been doing, which will make this next lesson make a lot of sense. I'm going to draw an XY axis, and I'm going to have a circle on it. Okay? And I'm going to talk about the unit circle. What is the radius of a unit circle? It is 1. Okay? So I'm going to go ahead and draw one of my reference triangles in the first quadrant. Goes to a point on the circle. Draw a vertical line down to the x-axis, and my angle theta is there. In the unit circle, the radius is 1. Okay? And I'm going to use SOHCAHTOA. So-ka-to-a. Okay? So I know where the hypotenuse is. That's here. It's across from the right angle. Looking at my reference angle, across from that is my opposite side, and next to my reference angle is the adjacent. Hypotenuse, opposite, adjacent. Should be okay with those by now. We've been using those quite a bit. Now, if I'm going to build sine here, I'm going to do opposite over hypotenuse. So sine, O over 1. Okay, so whenever we put something over 1, it's just the number that it is. But this is my opposite side here. And I want you to see is when I have a side that's up and down on my triangle, it is the y value. If it's going up, it's a positive y value. If it's going down, it's a negative y value. So if I'm down here, it's a negative y value. So watch what happens knowing that I'm going to call that y now. Hypotenuse is still 1. If I want to do the sine of my angle theta, it would be y over 1 or just y. Okay? So that's pretty cool. The sine of our reference angle is equal to the y value when the hypotenuse is equal to 1. Now, what do you think is going to happen with the cosine of this triangle? Okay? Let's go ahead and see what happens with the cosine. When I have the cosine of my reference angle, cosine is adjacent over hypotenuse. So, adjacent, when I travel left to right, it is the x value, okay? When I go in the positive x direction, it's a plus x, and if I was over here and went the negative direction, it would be a negative x. But let's see how this affects cosine. Cosine is adjacent over hypotenuse. The adjacent side to our reference angle here is our x value, and the hypotenuse is 1. Okay? That simplifies to just x, okay? But this is going to be true in all of the other quadrants, and the only thing that's going to change is maybe this is a positive y or a negative y, positive x, negative x, and we'll just always have to be careful with those plus and minuses. So this is going to be true, doesn't matter where my reference angle is. If it's down here, quadrant 2, 3, or 4, it's all going to still be the same. But looking at what I have there, and based on what I just said, I now know that the x value is here, is equal to the cosine of the angle. So I can label my x side of this triangle the cosine of the angle. Okay? And y is equal to the sine of the angle. So this is my y side, so this side of my right triangle is equal to the sine of an angle. Okay? That brings me to a really cool property that we're going to use today. And we're going to base it off the Pythagorean identity, and here it goes. So hopefully you have that written down. So remember that the unit circle, so we're going to start the notes page. The unit circle has a radius of 1, which we had in our diagram. Here's the radius of 1, okay? So the hypotenuse is always going to be equal to 1 in that unit circle. In the Pythagorean theorem, we can plug, now remember, Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared, okay? So sine squared plus cosine squared, those are my legs, equals the hypotenuse squared. And that way we come up with this formula. Sine squared plus cosine squared equals 1. So remember, the Pythagorean theorem looks like this. A squared plus b squared equals c squared. And the c is the hypotenuse, and our hypotenuse is 1. This is a really cool tool that we can use to solve these triangles, okay? And the only thing we'll have to be wary of is if we're going in the plus the positive or negative direction on the sides of our triangle for our final answer. So it's one last thing we'll have to do. Let's go ahead and do the first example. So here we go. In this first example, if sine squared, now, I want you to get used to one more thing I should comment. They're saying sine squared of 32. What they're saying is find the value of sine of 32 degrees and then square it, okay? In this one it says cosine squared of m. It's the same thing as saying cosine of whatever angle m is squared equals 1. So don't let this terminology fool you. It just means the sine of an angle squared or the cosine of an angle all squared. Okay? They don't want you to put the 2 on the end because then it'll look like the angle value squared. So that's how they rewrite that. Okay? So when we use this formula, notice in the formula that we're given up here, theta and theta. These two things are the same in the formula. We're talking about the same triangle, okay? Angle theta in each example is the same angle. If it's 30 degrees in the one, it's 30 degrees in the other. So in this case, if the sine of 32 degrees squared plus the cosine of 30, it would have to be 32 here. Okay? They have to be the same. So the answer to the first one is 32. All right, let's go down to our first exercise 2 example. Now, they're saying here, given that the sine of the angle is 3/5, where theta is an angle terminating in quadrant 1. Let's go ahead and draw the picture of an angle terminating in quadrant 1, okay? So, we're talking about the unit circle, and the reason I know that is they give me this formula, because they're saying sine squared plus cosine squared equals 1. 1 is the hypotenuse. Okay, because it's leg squared plus leg squared equals hypotenuse squared. Okay, so they're saying quadrant 1. That means my reference triangle would go in quadrant 1. Theta is here, right? And my hypotenuse here is here, and it is equal to 1. Now let's find O and A. My opposite side is here, and my next to adjacent side is here. When I did that opening example with you and using SOHCAHTOA, okay, using SOHCAHTOA, I know that opposite the right angle, if the hypotenuse is 1, this is sine of theta. Next to the right angle is cosine of theta. Sine of theta is equal to the y value, and cosine of theta is equal to the x direction. Okay? All right, let's go ahead and go back and read this. We've set up our problem. It says the sine of theta equals 3/5. Okay? So the sine of theta, or the y value, is equal to 3/5. Now, I'm going to have to go find the cosine value. They're asking me to find the cosine of the angle, and I'm going to have to find the x value when sine is 3/5. It's easy to do. Let's use this formula. The formula says the sine squared of our angle plus the cosine squared of our angle equals 1. They've given us the sine is 3/5, so I'm going to make the substitution for sine. This is going to be 3/5 squared plus cosine squared of theta equals 1. All right, 3/5 squared. When you have square a fraction, you square the numerator and you square the denominator. 3 squared is 9, and 5 squared is 25. That takes care of that. Plus cosine squared equals 1. Now, to solve for cosine squared, I'm going to subtract the 9/25 on both sides. Okay, 1 minus 9/25. I'm going to let my calculator do that for me. 1 minus fraction 9/25. And I get the answer of 16/25. Good. So the cosine squared of our angle equals 16/25. Now, they didn't ask me to find the cosine squared. They asked me to just find the cosine. So I have cosine squared here, To undo that, I'm going to take the square root of both sides. So take the square root of this side and take the square root of that whole thing. The square root of cosine squared is just cosine. And when you take the square root of fraction, you take the square root of the numerator and you take the square root of the denominator. The square root of 16 is 4 and the square root of 25 is 5. So I have the cosine equals 4 over 5. One last thing. Is it positive or is it negative? Looking that I'm in quadrant 1, okay? Cosine is the x direction of the triangle over here. I go from the origin and the positive x-axis, so cosine is positive. So this answer is done. Okay. So a lot of thinking parts to these. Let's get right into the next one. All right, in this one, they're saying given the cosine is this value, okay? If we look at our prior example here, we can see that cosine was on the x-axis, right? That's going to be the same here. This is going to be the x direction of my triangle because the cosine goes with the x direction, okay? And they've given us that. Theta is an angle terminating in quadrant 3. So let's draw a reference angle in quadrant 3. Okay, there's my reference triangle in quadrant 3. I drew the point down here in quadrant 3 and here's my reference angle. Let's label hypotenuse, opposite, and adjacent. Hypotenuse is here. I know that the hypotenuse is equal to 1 because they told me that this is true. Because remember, it's leg squared plus leg squared equals hypotenuse squared. So, which value travels in the x direction? That's the cosine. And this is the adjacent side to this, and this is the cosine value. Opposite, this is my opposite side. And the opposite goes with sine value. And the sine is associated with the y value, and the cosine is associated with the x value of the sides of the triangle. Now, they're telling me that the cosine is negative rad 2 over 3. And because the hypotenuse is 1, I can go ahead and label that side of my triangle cosine. This side of the triangle is negative rad 2 over 3. So negative rad 2 over 3 represents the x value. It is the cosine of the angle, and it is the adjacent side. 4 pieces of information there. So our job here is we need to go find the tan, okay? Using SOHCAHTOA, tan is formed by doing opposite over adjacent. Let's see if we have that. Here's the angle, O over A. I'm going to need this sine value to get the tangent of the angle. Okay, so I'm going to go ahead and use this formula, sine squared plus cosine squared equals 1, and solve for the missing sine value. I'm going to substitute my cosine value of negative rad 2 over 3 in for cosine here. So this becomes sine squared of theta plus, that is I'm going to substitute for cosine, negative rad 2 over 3 all squared equals 1. Do the math. Sine squared of theta stays the same. Plus, now I have a negative. A negative number squared is positive. And when you square a fraction, you square the top and you square the bottom. The square root of 2 squared is 2. 3 squared is 9. So, and then that takes care of that, equals 1. I'm going to get sine all by itself, so I'm going to subtract the 2 over 9. So I have sine squared of theta equals 1 minus the fraction 2 over 9. Definitely something I'm going to use my calculator for. 1 minus fraction 2 over 9. 7 over 9. Okay? So the sine of sine squared is 7 over 9. To undo the squared, I'm going to take the square root of this side, and if I take the square root of this side, I need to take the square root of that side. So over here, the square root of sine squared is just sine. And when you take the square root of fraction, take the square root of the top, that's square root of 7, and you take the square root of the bottom. Square root of 9 is 3. So now I have to go back and say, the last step is this positive or is this negative? So looking back at my reference triangle, looking at the side that I labeled sine or the y value, I went from the x-axis down, so this is negative. Okay, so I would want to remember that. Whatever I get for y here, it has to be negative. So my final answer, sine of theta equals negative rad 7 over 3. That works pretty good. Negative rad 7 over 3. All right, let's do another one. Using the identity. And sine squared plus cosine squared equals 1. Find the value of tan. So we're going to end up with tan that we're going to need to find. To the nearest hundredth. The only thing that's changing here is that they gave me a decimal for the side of that triangle. So let's go ahead and set this up. First thing I'm going to do is draw a reference angle in quadrant 2. Quadrant 2 is over here. The triangle always makes a right angle with the x-axis. And my reference angle is here. This is my opposite side. This is my adjacent side. And this is my hypotenuse, which is equal to 1. Okay? Now, they told me the cosine is negative 0.7. All right? So, thinking back, how is cosine formed? Well, let's write SOHCAHTOA out. Cosine is adjacent over hypotenuse. So, because the hypotenuse is 1, the adjacent side gets this label, and that's negative 0.7. And this is also equal to the cosine of theta. Okay? All right, the next thing we need to do is, this side is my hypotenuse, this side is equal to the sine theta over here. So using that Pythagorean identity, leg squared plus leg squared equals hypotenuse squared, I'll be able to solve for sine. So the sine squared of theta plus the cosine squared of theta equals 1. And they told me I'm going to substitute the cosine value they gave me of negative 0.7 for the cosine. And I'm going to bring down my sine. Okay, sine squared is what we're solving for, so that's going to stay the same. A negative 0.7 squared. So this is where you want to be careful with your parentheses on your calculator. So I'm going to use parentheses. Negative 0.7, close the parentheses, and square, enter. 0.49. Looked like there was a... Okay, equals 1. I'm going to subtract, I need to get sine by itself, subtract the 0.49. Sine squared of theta, 1 minus 0.49. I got 0.51. All right, now I'm not quite done yet because this says sine squared. I need to take the square root here and the square root here. So this would be sine of theta after the square root is taken, and the square root of 0.51. I'm going to let the calculator do that. Is 0.714. I think I'll take that much of it. 0.714. Why did I pick 3 places? Hundredth is 2 places, and we need to round off 2 places, so I'm just going to keep 1 more place there. All right, so the sine is 0.714, which means I know the side of this sine side of the triangle is 0.714. Okay. All right. The last step was find the tangent. I have the full triangle filled out, and now I should be able to find the tangent. So tangent is formed by O over A. So the tangent of our reference angle theta is O, 0.714, over A, negative 0.7, and tangent of theta, I should be able to tap that into the calculator. And I said 0.714 divided by negative 0.7. Negative 1.02. Okay, and that's already rounded off to the nearest hundredth, so it looks like we're good. Tangent is negative. Done with that. Let's do one more. If you want to pause the video, try this one, and then come back and check your answer. That's probably a great idea. It says, using the identity sine squared plus cosine squared equals 1. So again, this tells me that my hypotenuse is 1. Find the value of tan to the nearest hundredth if sine is that, and theta is in quadrant 4. So my reference angle is going to be drawn in quadrant 4. Okay, so drawing my reference angle in quadrant 4. Okay, so we said the hypotenuse of the triangle is 1, the hypotenuse crossing the right angle, the hypotenuse equals 1. Across from the angle is my opposite side, and next to is my adjacent side. Okay, and I know that going, sorry I bumped that, going across or the opposite side is always the sine of the angle. And that's because S is O over H. Cosine is A over H. So this is my cosine value on that side. All right. And this top of the triangle here travels in the X direction. So this could also be known as X. This travels up and down in the Y direction. So this could also be known as Y. Lots of information. All right. Let's go figure this out. They told me that the sine is negative 0.5. So this side of my triangle here is negative 0.5. All right, I'm going to need, in order to get tangent, I'm going to need, using SOHCAHTOA, TOA is O over A. So I'm going to need opposite over adjacent, and I don't have a value for the adjacent side. So let's go ahead and figure that out. I'm going to use their formula here to find the cosine value. So sine squared plus cosine squared equals 1. Sine is negative 0.5 squared plus cosine squared equals 1. Negative 0.5 squared. Is 0.25. Okay, I'm going to subtract that 0.25. We should be able to do that part in our head. 1 minus 0.25 is 0.75. All right, cosine squared equals 0.75. It's cosine squared, so I have to take the square root to get cosine by itself, which means I need to take the square root of that side. This becomes cosine of angle theta. And what is the square root of 0.75? Let me get the calculator to do that for me. Control square root 0.75. 0.866. How many places we round off? Hundredth. Hundredth is 2 places, so I'm going to carry this for 3 places. I'm going to carry 0.866. All right, so the cosine is 0.866, which labels this side of the triangle. Cosine 0.866. Now, the last thing I needed to do was find the tangent. Before I go to do tangent, let's look at these values I have. The y value I have is negative because I went down from the x-axis. That's how we travel negative value for y. Now, I went from my origin in the positive x direction, so this 0.866 is positive. So that's all done. We definitely need to take a thought about that before we get our final answer. So, tan, using SOHCAHTOA. Okay, tan is O over A. So, the tangent of my angle theta, O, is negative 0.5. And A is a positive 0.866. let's just go ahead and do that division in our calculator and get our final answer. Negative 0.5 divided by 0.866. And I got negative 0.577. All right, and they said to round off hundredth, that's 2 places. So my tangent of my angle equals negative 0.58. All right, let you see that. All right, so we only have one more, or this is the final lesson in this part of the unit. So these triangles aren't going to go away forever, but we're going to start like as a different topic with sine and cosine in the next lesson next week. So, but I want you to do for the homework for this assignment, I cut it back from what they gave me. I gave you 4 problems to do on this next page on your own, and I'm going to go ahead and post those solutions, but here's how you would turn in your work. I don't like the stuff on Delta Math, so, and I'd like to see your work. So upload a pic of this page only on the Google Drive where I made the assignment. You know, you click on it, it creates a blank space, upload your photo there. If that's too much trouble for you, just pop that photo of that picture off to me in an email. And if you use a personal email to do that, let me know who you are, because some of you have crazy email addresses and I don't know who you are right away. Send me the photo either way. I will get it either way to put it in your school 2 grade. So I'm going to post the answers to this to help you work through it as well. And I will see you on the next video. Bye.